Good afternoon, everyone, and welcome back to the this third day FDP program of the digital transformation in additive manufacturing. Today, we will take a 4-hour complete lab session on the wire arc additive manufacturing, in which from the basic scratch to the how we experiment on the wire arc additive manufacturing, we will see that. In that, firstly, we will see what is the wire arc additive manufacturing, how it is different from the other manufacturing processes, what are the components are needed in the wire arc additive manufacturing process. Along with that, what kind of materials, strategies, and how we perform the experiment on this particular setup that we will see. Initially, I will start about the what is the wire arc additive manufacturing. Before that, I would like to say that wire arc additive manufacturing is a part of additive manufacturing process. So if I define what is additive manufacturing process, so additive manufacturing is a process of making a 3D geometry through the layer by layer. If I classify this additive manufacturing process as per ASTM standards, it can be categorized in 7 different types depending upon the energy consumption. It can classify it from wet photopolymerization. In wet photopolymerization, material jetting, binder jetting, material extrusion, sheet lamination, then powder bed fusion, and then last comes into the category of the directed energy deposition. This specific classification is on the basis of how energy, what amount of energy consumption is taking place in particular additive manufacturing process. But when depending upon the material and the equipment, energy sources, and the available raw material, different additive manufacturing processes are used, in which for directed energy deposition process directly classified, if we are using as raw material in the we can use raw material in the form of powder, in the form of the wire, in the any other. If we are using the metal part, then most prominently 2 types of additive manufacturing process are used. That is LPBF process, and another is directed energy deposition process. For the powder part manufacturing, LPBF process are used. But when we take the consideration of the direct energy deposition, a thermal energy is used to melt the raw material and to deposit it on a create a complete 3D design. Although up to this FTP that you have already aware about the what is the additive manufacturing process and how the 3D printing takes place, how the complete part geometry converted from the scratch you want to create a part. Then firstly you have to take its CAD model, then you have to go for the slicing, and then after that you will generate the STL to get some codes in like a geometry codes and the miscellaneous code that is also called as the G code and M code. To those codes, you use the CNC controller, and as per the tool path planning that you have given, it deposited complete the material. So now I will talk about the wire arc additive manufacturing. As I told you that wire arc additive manufacturing is a part of directed energy deposition method, in which wire as a form of the raw material and thermal energy is used as to melt the raw material and deposit and making it completely 3D model and 3D part. So now in wire arc additive manufacturing, as I told you, depending upon the raw material, depending upon the energy source, they can further classified in terms of like wire arc additive manufacturing through GMAW, that means gas metal arc welding, wire arc additive manufacturing through GTAW, gas tungsten arc welding, wire arc additive manufacturing through the plasma arc welding, and wire arc additive manufacturing through cold metal transfer technique. That what is the cold metal transfer technique? You have just about learned the cold metal transfer technique about the previous lecture through the Dr. Yashwant Kohli. So we will see further that in this particular lab setup, what we are going to do. Firstly, we will work on the basic setup, that is the wire arc additive manufacturing through GMAW. That means with the help of the MIG machine as a thermal power energy source to melt the material, we are going to use the MIG power source. And another is the raw material, that as is it form about the wire arc additive manufacturing, we are going to take wire in the form of the raw material. Now, in the this particular live session that is designed for in this FDP, that is considered the 4 hours, that we will split in 2 hours session, and the secondary part will be taken by the Dr. Yashwant Kohli, and he will tell you about the advanced part that I will demonstrate over here. So firstly, what we will do, how we create a part. Suppose we want to deposit a single wall structure. For that, what processing that we will use, that we will see. Initially, first we run some experiment on the bead on plate experiment. What is the bead on plate? It is just only creating a bead on a substrate plate, that depending upon the material that you want to deposit. And after that, how we decided in this, that how to we have to deposit this bead on plate, that we deposit all the bead on the basis of the process parameters that we required. One most important thing in any additive manufacturing process is the process parameters, and all the process parameters are designed in such a manner that it should give the higher resultant properties that we want as per our functioning requirement of the material. Like if we want some higher mechanical strength, some higher greater corrosion properties, that we need to define the process parameter in such a way that the grains structure or the microstructures that we got should in such a way that the material get the higher properties, higher mechanical properties, and the other properties as well. So in any additive manufacturing process, the most important part is the process parameter. After the process parameters, every process parameters, because in all the properties that we required for functioning it, actually the component whatever we are manufacturing, it has its some functionality. To fulfill the functionality, it's required some properties, and all the properties are related to the microstructure that the component possess. So the microstructure, the grain orientation, everything is very, very important for any additively manufactured part. So to control those structures, we need process parameters, and every single process parameters affect in a different way to the additively manufactured part. So now I will show you why we are using the wire arc additive manufacturing process, because it has the greater deposition rate in any other among the processes. So here I will show you some typical setup of wire arc additive manufacturing process, in which we are using a GMAW and gas metal arc welding process as a power source, and the wire as a raw material as a feedstock, and the power source will use to melt this raw material, and deposition will take place. So initially I have classified the wire arc additive manufacturing in 3 parts. The wire arc additive manufacturing in the 3 parts. Initially I have already classified the wire arc additive manufacturing in the 3 parts, that is the 3 types. One was with the GMAW, and one was with the GTAW, and one was the plasma arc welding, and some technique can be done, the deposition can be done with the help of the electron beam process. But the highest deposition rate that we get with the help of GMAW process, because other processes have some challenges related to the wire arc additive manufacturing process. Like in EBM, we require the vacuum environment to perform the experiment, and the GTAW process also leads to the lower deposition rate as comparatively to GMAW process. So that's why we are the setup that I am going to demonstrate is based on the simple GMAW based process, which has its advanced version is known as the wire arc additive manufacturing through CMT, that is the cold metal transfer mechanism. That is only the advanced version of the GMAW process. Now, in this typical setup, there are the few components. One, we need an robotic arm. Another that we need a CNC controller. Another that we need a specific power supply that we are using the GMAW process. So keep in mind the sequence that I am going to elaborate why we are using this. So everything has its reason. So initially we chooses the GMAW power source that I explained to you. Why we choose that? Because it gives the maximum deposition rate up to 4 to 5 kg per hour. And after that, we choose as a wire as a raw material. Then we uses a robotic arm, or for that, for controlling that we needed a CNC controller. And to protect the during the deposition, that we need a shielding gas cylinder that we uses over here. So here I'm going to show you some parts of this particular setup that I told you, and how this process will take place. Initially, first, this is a GMAW power source that you can see over here. Is it visible? This is the GMAW power source specifically, and it considered two main process parameters, that is the ampere and the voltage, that is the current and the voltage process parameter that it considered, and the wire feed speed through this setup is controlled by through the welding current. After that, this particular setup that we are seeing, this is CNC controller and router setup. This is basically what? CNC controller and router setup, in which let me see. This is specifically is the CNC router part. CNC router part. Then what is CNC router? It is X, Y, Z direction control, or basically a CNC robot. In case of the CNC robot, so already we know that is very expensive part, up to 50 lakh, 60 lakh. So this is the typical setup that is a very in the less cost. So this axis movement is the both X and Y and Z direction. Then I will demonstrate you how the movement will take place. This particular is known as the bed, CNC bed, and the material of the CNC bed is 6061 aluminum or 6063 hard aluminum material is used, because for the some we need some hardness as well as some lightness of the weight overall the machine. So if I talk about the complete working area of this particular part, that is the 590 by 390 mm is the complete working area of this working table. Up to that, in the Z direction, that we can move up to 70 mm. That means if this Z is stroke, this in the Z direction, that we can move up to 70 mm, and the maximum part height that we can achieve is less than up to 105 mm. 105 mm. So this particular router has three axis control. It's X, Y, Z. All the control is done with the help of three servo motors. With the help of three servo motors, those are attached with the lead screw and then ball screw to move in the to and fro direction. This controller, this CNC router is connected with the controller to the drag cable, and the drag this controller consists of number of PLCs and the other electronics parts that complete make it available. This CNC router can work either through the software basis or through the manual basis. This is known as MPG support. What is manual programming support? With the help of this, I will show you right after this. After demonstrating the every part, I will show you how this part will move on. So this part can control to the manual controlling, and the Mac 3 mill software is used for operating only directly automatic mode. So till now, I have shown only three parts. First one is the GMAW power source, which is used in the direct energy deposition for melting of the feedstock that we are choosing as a in form of the wire. I have shown you the X by the CNC controller and router. This part is known as the router. Material of this base material is the aluminum 6061, and it can move in X, Y, and Z direction. That I will demonstrate after the explaining the all the component. This part is the controller part, in which directly we can operate this through the manually as well as on the basis of the software. For manual application that we needed this MPG support. This MPG controller will lead to the movement of in the X, Y, and Z direction. And for the software that we use is the Mac 3 mill software in which all the process planning takes place through automatically. Now, the fourth part is shown over here. That is the wire feeder. That is the wire feeder. And the fifth part is the sealing gas cylinder. In this particular case that we are using at 99% pure argon gas as a shielding gas, and this is the wire feeder. Notably part is that this particular machine is designed for two twin wire arc additive manufacturing. What is that? Basically, in this setup, simultaneously we can use two torches, yeah, to make torches or to make power source that we can use. But right now, it is only the single power source is applied over here. So this is the basically to hold the torch. This is the manual make torch that we can hold that can act as a CNC robot. That can act as a CNC robot. And after that, for if we want to use another torch, that we have to hold it over here, and we also some changes in the connections also. So if we want to run this setup on MPG mode, that is what the manual programmable mode, that we need to change some behind. Then we have to change this part. This is what this is DDCS controller. This is what DDCS controller, direct digital controller. For to operate on the software basis, we need to change this knob that is known as the Mac 3 software. For MPG support, we have to change this. And another one feature is that, as I have told you about the three servo motors that are placed over here for the movement in the X, Y, and Z direction. Now, if I talk about the GMAW machine, it is the basic GMAW setup, GMAW machine over here for melting, for giving the edge and thermal energy power source. It has include arc and voltage. The most important thing that is keep in consideration during this machine. Otherwise, when you experiment, there were a lot of challenges that we face generally. That in this particular machine, the mode should be in a GMAW mode. The most important part is that the GMAW mode should be on. Another part is that you are using as a solid wire for depositing the material. So you should mention that you should be okay before operating this machine that your mode is on the basis of the solid. There is another knob is given 0.81, 1.2. This is basically showing the typical diameter of the wire that you are using before the deposition. If your wire material, if wire diameter is 0.8, then you have to fix it at the 0.8. If it is on 1.2 or 1.6, then you have to change accordingly. So these are some basic considerations that has to keep in mind. Otherwise, during the operation, even single mistake will lead to the complete setup, complete experimental failure. So another part is that this is what the wire. This is what wire feeder that we talk about that. Along with that, the wire comes through the rollers into the torch, and the roller should be the as per the wire dimension. Keep in mind what I have said, that the roller diameter should be as per wire dimension. Otherwise, it will slip in that case, and it will bound over there, and your experiment will get failure. Wire diameter we are using here. This material is specifically for the experimental purpose we are taking, that is S308L, and in which the wire diameter is the 0.8. For the wire diameter to having the 0.8, we have taken the roller of 0.8 diameter. Here we have changed. Here we have changed the diameter to the 0.8. After that, we have mentioned in the GMAW part, and another part is the solid part that are very basic considerable need. Otherwise, experimental will get the failure, and you will not get appropriate results as you desire. So these are the basic setup. Now I will tell you about the software part. Suppose how we can start. Okay. So now
The five different.
so,
Five.
नहीं वो चेंज कर सकता एंगल चेंज नहीं हो सकता इस साइड से डिफरेंट हाइट से आगे नहीं लेकिन थोड़ा टास्क में डिफरेंट मतलब डॉट्स मैं तो बैठ में अगर सामने खड़े क्या चीज
नीचे करना।
पीछे करना
हाँ बस।
साइड पे से कैमरा करके देखिए so now, as you can see that I have told you about this MPG part that you can see how with the help of this MPG manual programming part that I can move in X and Y Z direction. That you can see this controller is moving in X direction. In X direction, we have standardized this. That is this is what the X direction. This is what Y direction, and in the vertical direction, this is the Z direction. Accordingly, as per horizon, the one is a positive Z direction, another one is a negative Z direction. Similarly, one is positive X direction, another one is a negative X direction. Here, that we can see, this is what the positive. Similarly, this is direction, and if I change this move from Y direction, then it will move up, forward, and the backward direction. If I move this to the Z direction, then it will move up and down. So we have to control this.
29.
So now we will see the software part, how with the help of the software, how we operate. So as I mentioned to you, if we have to operate in the software mode, then we have to change the backside setting that we have to go for the Mac 3 software. So we have changed the both the Mac 3 software. Now how the software looks like.
नीचे नहीं होगा क्या? उसी स्क्रीन पे व्हाट्सएप में ऑन है वैसे।
कोई नहीं ऐसे दिख रहा है
तो रिफ्लेक्शन क्या?
So this is the interface of the Mac 3 software that we see. Initially that we have after starting this, then we have to, it is showing some configuration, that means reconfiguration e-stop, that is showing that emergency stop. For that, after opening this software, then we have to go for the reset. Then it is showing that RNC motion is not found. Matlab, that means that we have started the software, but we have not inserted the controller part to this software. So what we will do, and we will use this cable to connect this software, this controller to the software. After this, we have to change from mode over here. Then we have to go in the continuous mode. And once we go to the continuous mode, then again go to the reset. Then it is showing e-stop configuration. Then now you can see there is no problem it is showing. If it is show the emergency stop, that it shows about the that configuration card is not connected. Then we put the controller, then we attach the controller part to software. After that, then we will use the tab button for giving this title of is to moving the keys in the X, Y, and Z direction. So here, from here onwards in the software, that we can move in the X positive direction, that we can move in the X negative direction, Y positive, Y negative, Z positive, and Z negative. Along with that, we can also control the motion speed by changing the rate percentage. Here it is showing the 20%. If we reduce it, the 15% or 10%, the speed of the jog motion will be slow. And if it increases, accordingly, the speed will be very higher. Here, before starting the experiment, what we do initially that I told you that in any additive manufacturing part that we want to deposit, what we do initially we create a CAD file. After that, we go for the slicing and slicing that after the slicing we generate the codes, that is the geometry code and miscellaneous code, G codes and M code, and those codes are put directly either through directly through the this CNC controller for depositing the material. So either we can take those code in the pen drive and put in this slot and controller can operate, or we can manually put in the program, we can manually put in the software and make it run for depositing the material. So here I will show you some recent files. Yeah, so here is a program. So here is a program that is showing on your screen, that is it's M3 G01 X80 F240 Z01 Z2 M5 M30. So what all we all needed this kind of programming to run any experiment and to make the material deposit. So what is showing? Firstly, as I told you, this machine setup was initially was made for the two torch, yani twin wire arc additive manufacturing, but we uses here only one torch. So that's why we uses the code M3. M3 will lead to starting of the torch. M3 will lead to the starting of the torch. Then this is the G01 X80 F240. What is it? X80, that means that you want the movement of the 80 mm in the X direction. F is showing the feed and G01 is the coding to move that in the incremental mode. Similarly, what you want, suppose you want to deposit a single layer bead on a plate having the distance of 80 mm. 80 mm bead that you want to deposit. That means you have to go from here to here up to 80 mm. So the programming we have given in the X direction that we want 80 mm, and the speed that we want with the yani speed, that means the travel torch speed will move on. So it is basically the 4 mm per second is the speed is given to it, right? So next, what we want just deposit only single bead and just stop the program up directly. What will happen if we will directly stop over here? Then there is a chances. Then there are chances there will be a welding between the wire and the melted material already. So that's why firstly we deposit a bead and then move to the tool upside, and then after that we stop the program. So that's why the program is showing that M30 is giving the torch starting. Then after that we move the X80 with a speed of 4 mm per second. Then after reaching to the end point, then the torch will go upside of the 2 mm in the Z direction, that is 2 mm. Then M5 will be the end stop of the torch, and then M3 is the ending of the programming. So such kind of G code and M code that we needed, codes are needed for depositing any material. Now, till now we have talked about the machine, CNC controller, Mac software, how it operates, what is the G code, what is the M code, different combination as per your design, as per your requirement. Then we can changes the G code and the M code. If we want to make a circular design, that we need to use another types of the G code, and that we if we want to deposit in a complete way of the programming, that we need to give some dwell time also. So that depend upon the design and the part that you want to fabricate or you want to deposit. So now, main important thing before depositing any material in the additive manufacturing, the main important part is the deposition strategy. deposition strategy is one of the key component, a key process parameter that will define the properties of your material that is being deposited, and all the properties will leads to the functionality of your component. So that deposition strategy is one of the main important parameter. Either we can deposit in a single base direction, or bi-directional deposition can be pattern can be taken. Multi-directional, multi-layer deposition can be taken, and single track multi-layer deposition can be taken. Multi-track, multi-layer deposition can also takes place. So this is all about the thing. So now we will see how the machine works actually. And in the machine, how we proceed for being from the scratch, we want to just deposit. In which direction then we have to deposit? That initially to deposit any material, first we need some trial experiment. Why trial experiment? To find out some range of the process parameters of regarding that particular material. As I initially mentioned you, that process parameters are the key of any deposition in additive manufacturing. So we have to find some process parameter range, that in which range that the deposition is getting good or bad. After getting those parameters, then we go for that design expert tool. What is design expert tool? Design of experiment or design expert tool gives you the optimum number of experiment that you have to run. How design expert works, it will be shown to you by Dr. Yashwant Puri sir in the software program and the upcoming class of today onwards. So with the help of the design expert, with using a proper design of experiment, we get the desired number of experiment that we have to perform. Randomly we can't do the we can't deposit material and conclude our part, and we can say that this is the best part. No, it have to be optimized, and on the basis of the process parameters, on the basis of the material using, everything should be the optimized. For optimization, that we needed some design of experiment and design of experimental basis data. For that, what we do initially, with the help of hit and trial, we run some experiment and find some range of the process parameter. On the basis of those process parameter, we go in the design expert or design of experiment. Design of experimental, that can be another done with the different software also. With the help of design expert, we get some number of desired we get number of desired experimental run that we need to conduct in order to get optimized data. What is the mean of the optimized data? Suppose we want to deposit a material or single wheel material. So what is our objective? Our objective is to create a 3D printed part. So during the deposition, what we want, sir, we want the higher reinforcement part. Higher reinforcement part, that means lower penetration. That means lower dilution percentage is needed. For that, what we have to see? We have to see through the trial and experiment what is the appropriate optimum range of the process parameter in which we get some effective bead height, effective bead area, minimum dilution, proper reinforcement. So all these parameters we have to need to check it out. For that, what we need, we, as per our requirement, as we have to deposit the material, so we need higher reinforcement area. So what we did, with the different process parameter combinations and their variations, we deposited the bead, and after taking their cross section and analyzing through the software, we conclude a optimum value of the all the process parameter that will give you the best profile of the bead, that will lead to the best profile of your making component, that will lead to the best mechanical and the other desirable property to fulfill the functionality of your product. So this is the whole case scenario in which here we will see how the bead and plate experiment takes place, some with the help of the single directional strategy or single directional, and other with the multi-directional tool. multi-directional strategy. So as I told you, the directional strategy play an important role. Why directional strategy play an important role? Because material property, whatever the part that we want to deposit, we want all the properties should be uniform throughout the part. As the deposition strategy changes, its material property to the directional to directional is changes. That is also known as the anisotropy. To reduce the anisotropy of a component, we need a optimum deposition strategy, and after that we deposit and analyze it and go for the final component for having the better properties. I think you all have got the idea about what we are going to do in this part. Now we will go for a bead on plate experiment. What are the setup needed that I have told you? If I summarize all over things, initially I talk about the wire arc additive manufacturing, types of wire arc additive manufacturing. Then I went for the setup. Then I talk about the CNC router, its material, then about the controller, its mode of operation, either through the DDCS or MPG support, or either to the software basis. Then we go for the software part, in that programming part, then the G code, M code part. Then I talk about the deposition strategy. Then I talk about the I talk about the wire feeder, then argon gas cylinder. So all these things I have talked about. Now we will move for the experimental part. We will set up. It will take within 5 to 10 minutes to set up this, and then we will move on for the experiment of the single bead deposition. हाँ भी वहां से निकाला निखिल निखिल वेल्डिंग स्पीड की क्या इसमें देखना इसमें क्या
अबे इसको चेंज कर, इसको चेंज करना पड़ेगा ओरिएंटेशन। तूने बंद कर दिया इधर। नहीं आपको देखने का आगे ना हाँ
So here we are going to deposit a material that is SS308L, a grade of stainless steel, in which the amount of carbon content is very low. That's why it is noted as 308L. So for depositing this, that we are using some process parameters. How we got that process parameter? As I earlier told you, on the basis of some hit and trial experiment on some steady state response, we got some range of the process parameters. And in the what are the process parameters in this process? That is the voltage, current, and the wire feed speed, and the torch traveling speed, shielding gas, and nozzle to this nozzle to tip distance. All those are the process parameters in which we consider some process parameters stationary or keeping them constant in the range, and through the literature and on the basis of the variation of 2 or 3 process parameters, then we conduct the experiment on the basis of design expert uh, experimental run that given to us. Okay. So before after what we have to check initially the this is the GMAW complete setup, the machine, the torch part, the earthing part, and the workpiece part. This is the conventional GMAW setup in which the torch and the workpiece given the different polarity. As we all know about the straight polarity and the reverse polarity, straight polarity leads to the workpiece is a positive part and the torch is given, that means the electrode is given the negative part, and in the reverse polarity the electrode is given the what negative part, electrode is given the positive part and the workpiece is given the negative part. Here in this case if I define which kind of polarity is given, because as we want the higher deposition should be takes place, higher deposition should be taken place. So for that the electrode wire is given the positive part and the workpiece given the negative part, so that the maximum amount of energy and 2/3 amount of energy generated in the zone should go to the electrode part and the melting of the wire should take place. So I think I got the point that why we taken this part as positive and this part as grounded part. That's video. So for that, most important thing before starting the process that you have to see the nozzle to standoff distance, nozzle to surface distance. It should be in the range for the operating the experiment. Another thing, the process parameters that you are choosing here, as per our trial experiment, we got some ranges from 22 volt to 26 volt for this particular specific material SS308N. So here I am showing you on the 24 volt as a as a one process parameters, and in the GMAW process, wire arc, uh, uh, wire feed speed and the current are directly connected to each other. So wire feed speed is directly controlled by the current value, and as per the trial experiment we are taking the current value up to in the range of 100 ampere so that melting takes place. And यहाँ पे सेट कर लेगा, यहाँ सेट कर देगा वायर फीड ऑटोमेटिकली करंट के अकॉर्डिंगली सेट हो जाता है, सेट हो जाता है. That depends upon, and in some wire feeder there is a no to control the wire feed speed, but in some cases only through the current value it get automatically settled. Third important part that we have to control the shielding rate, shielding and gas flow rate of the argon gas. So in that case, this is also one of the parameters that one can do the experimentation by changing the different gas flow rate also. So we are taking here the constant up to 15 mm per liter, and after that we have to just check that out the amount of the voltage. And initially, I have told you the key important points that in the machine that you have checked, it should be in the GMAW mode, it should be in the solid wire mode, and it should be in the as per your wire diameter dimension. Here we are using 0.8 mm wire diameter. We have specified in this particular machine. A controller is connected to the software part, and gas is on what? Up to 50 liter gas flow rate, 50 liter per mm. And gas flow rate is mentioned over here. So now we are going to just start programming. What we have to do, everything machine is completely set up right now. Now we have to take care about the program part. Program part that I have already told here in the software. Before starting the deposition, first we need to set the origin with the help of this x0, y0, z0. That means at whatever position your torch is, this is known as your origin position. From here in this direction, this is positive x direction. In this direction, this is negative x direction. This direction positive, this direction negative y. Then again above it will be a positive z, and in the downward it will be the negative z. So first needed the to set completely 0 0 0 condition, that means the origin condition. Now we will go for the recent files. Here we want to deposit a single bead. Single bead in that sense, that is that we are depositing here linear programming. So here I have already told you about the every code means what is showing. It is showing M3. Again, I am repeating M3 for the torch. The torch that we have used the one torch. If we will use both two torch or two both torches, then the program is starting will be from M3 and M7. M3 and M7. And here only one torch. It is so that's it's why from M3. And after that programming that we want to run deposit a bead up to the 80 centimeter, sorry 80 then the feed is given to here as another process parameter. That here we are taking two process parameter that we are changing. One is the voltage and another one is the travel speed or torch speed, or that we can say that feed to the machine. So here we have chosen the 240. That means approximately 4 per second. Okay. So after that, after depositing this, it will what we want. I have earlier told you that it's if we directly close the program, that the wire get welded to the melted part. So we don't want it. So for that we want some spacing. So in that direction that we want Z should go up for the 2 and then program should stop. Right. So everything is okay. And we have to start the machine. So important part is that to operate any machine, we need some safety equipments and safety requirement is needed. So for here, as for the welding shield is needed. So this is the welding shield, protecting shield from the UV rays. So we are going to just start the program.
आप सबके इसमें सभी लोग यहाँ तो दिक्कत नहीं
Here you can see that this specific bead is being deposited. This single layer bead is deposited through this setup. So here you can see that the quality of this bead is very straight and the very dense bead that we have got as a specific process parameter. This is known as unidirectional deposition strategy. This is what known as unidirectional deposition strategy for a single layer. If I want to deposit a complete wall, that what we can do, either we start the machine from continuously here to here to here. That means the unidirectional that we can move. And if we want to change the deposition strategy, then we can go in the bi-directional, like in the x direction, then again, and again, then इस तरीके से continuous to and fro motion can be done, and the deposition can takes place. Every deposition, as we move on, that as height will increase, there is a chances some being defected part or the defect like porosity and all that can experimentally. Here some black carbon is also you can see this is due to the some lack of gas flow rate. If we increase the gas flow rate also, that this can also be encountered. Although important part is that here I want to add on that to get a proper beat, to get a proper deposition, the first thing is that that environment is a very impactful. So clean the your substrate plate is a very important part. So cleaning is a very important part. Otherwise, there are chances of some defects also in that deposition part. So now we will do some experimental part for if we again deposit on this. Let's see what happens. वो प्रोग्राम में सेट नहीं करता. And one thing keep in mind, after one run, if we want, we can also run continuously itself also, but I'm doing this in a manual way. So after one deposition, what we have to do, you can see here a global is formed in the wire. At the edges, its global is formed in the wire. It should be cut out, otherwise it will. So now again we have to do the origin set. That means x0, y0, z0. So we are going to start it again, the same program up to the same line. So here you can see that two layers has been deposited of this. You can see here again global system. That's okay. Okay. So now again we are going to set origin. So we are going to again start it. Here you can see at the end there is a formula red hot globules. If we will not cut it, it get welded over here. So that's why I mentioned you that we need some Z height to before ending the program. get yeah. So again, we have to do origin set. So at the end, it always create a some globules form. So we have to cut that out before everyone. That's beat बनना है. सही है ना? So here what we have deposited, we have deposited 5 layer in a single track. Yani single track unidirectional 5 layer deposition. So what we have did, we use the deposition strategy in unidirectional. First we go from this A to B, then again we will reach to the again A, then deposition will started. After that, we will see again the 5 layer of deposition with the bidirectional deposition strategy. That means we will go from A to B, and then the second layer we will go from B to directly A. For that, we need to change some setup requirement for the substrate plate. And here also one thing that can be seen, that here, as you see, in this particular bead, there is a defect is being continuously created, that it is not coming properly to the single layer because of the accuracy. So this kind of defect is known as staircase defect. This is known as what? Staircase defect, that you can see over here. Although bead quality is very good, but there is also some defect also over there. This is known as what? Staircase defect. Then steps are being formed in the part. So now we will move on to the bidirectional strategy.
पाँच मिनट का ब्रेक ले लो, 5 मिनट, 3 बजे है ना, 5 मिनट का ब्रेक ले लेते हैं, फिर तो 5 तक हो सकती है, तब तक इसको सेट कर देंगे 5 मिनट तक।
Everyone present online, we're having a 10 minutes break. We'll resume shortly. Please stay connected.